What's up everyone, Simulator Shane here. It's been a while since my last video update, so I figured I'd bring you up to speed with what's going on in the project. I've been doing a lot of research and developing, so that's pretty much just me sitting on the computer, experimenting with code and sort of testing out the theories that are in my head. So it's kind of been boring, so I haven't really been showing it, but I'm starting to progress beyond that stage into like an integration and testing stage, so starting to put the finished concepts into the actual cockpit and sort of see them interact together. So I'm going to start doing more videos because that's where it kind of gets interesting. So I'll just give you guys an update. So one of the systems that I've been working on is the governor throttle operation. So basically this is the collective here. You've got the throttle, which is a twist grip on the end, and then you've got a governor motor here, which is controlled by a governor sort of computer, I guess you would call it. And then basically just turns the throttle and makes fine adjustments for you. So I've been working on making the motor actually work and affect the throttle in the simulator. So I've got a 5 and a 12 volt power supply there hooked up to the Arduino, and that's a motor driver which is driving the 12 volt gear motor, which is the governor actuator, and that moves this whole bar so that both throttles move at the same time. And then right here I've engineered this little 3D printed part to hold the throttle potentiometer so that it senses the movement on the throttle. So combining this sensor reading the throttle position and the motor driver driving the governor motor, I can actually have the full feedback loop system. And I've gotten it working to the point where it'll drive the throttle in the correct direction. Now I just need to tune it so it actually homes in on where the throttle should be. Another thing I've been working on is changing the temporary wiring that I had for the switches at the front of the console here, and changing that to a more permanent solution. So basically there's a few switches along here, and I just had the wires sort of clamped on there in a very temporary way, but I've just been sort of converting them all to more, like I said, more permanent solutions, so something that I can take in and out of the cockpit. So I've got full sort of mini Molex connectors here, and then all crimped onto the actual switches. So you can take it in and out of the cockpit and do testing separately, or obviously install it into the cockpit and have it work as it should be. One of the most important things in any flight simulator, but especially a helicopter flight simulator, is the sensitivity of the flight controls and how accurately they transform the movements of the flight controls in the cockpit into the computer. So you can see here I've started working on the pedals, which is driven from the pedals in the cockpit. As you can see, both of them are moving there. Goes up the broom closet up to this rear linkage, and then this would ordinarily go back to the actual tail rotor. But here I've 3D printed a linkage here, and then a down linkage here to a potentiometer, and that connects into the computer. The problem I'm having is this potentiometer is really cheap, and it's fixed to 300 degrees rotation, and as you can see, the actual movement that it's sensing is only about 30 or 40 degrees. So I'm trying to come up with a better system that is more matched to the actual movement so that it uses the full range, but it's coming along quite well. Something else that I'm really excited to be working on, and it's really fun when it actually works, is the intercom system. So I have a real aviation intercom that's for an actual aircraft here. Bought that brand new, and then I have a helicopter headset with the single jack, and then I have my old GA headset. It's a Lightspeed Zulu, which has the dual GA plugs. And I've test wired, obviously it's a mess here, but this is just test wiring. Test wired, then they've got power there, one of the headsets, two of the headsets, and it all goes into this wiring loom which goes into the intercom. And both of the headsets feed back to each other and themselves, so you get the full effect of a real intercom. And one of the cool features of this intercom is you've got an aux jack here, so you can actually plug in a music source and listen to music while you're flying. And it actually dims the music a little bit when you intercom between the headsets, so the music goes from full volume down to like 30% and then fades back in. So that's pretty cool. I'm looking forward to that working in the actual cockpit. As far as the actual cockpit goes, it's pretty bare right now. It's just got the cyclic system installed and the pedals obviously, and then it's got this monitor just for testing purposes, so when I need to do a quick flight I can throw the instruments up on there. And then I've just got a bed sheet hanging up here to be the forward facing screen. Obviously it's going to be full wraparound screen when it's all done. And then I've got the cockpit lining there, so that goes on the roof, and then I've got one of the seat rest backs there. I've got the speakers, and then some of the panels, that's the R22 panel, and then some cyclic boots to clean up and install into the cockpit. So right now it's still pretty much completely empty, just sort of some functional pieces here and there, but I'm going to start actually putting all the furnishings in to make it look like a cockpit again. And the other thing that's been taking a lot of my time is developing the instruments. So you can see here the main instrument cluster, the carb temp, and the engine and rotor RPM gauge. All three of these instruments are from the real aircraft, and they've been stripped down on the inside, and then I've 3D printed or designed and 3D printed mechanisms that go on the inside to hold servo motors that are attached to the needles, which are also 3D printed, which move obviously when the real gauges in the simulation program move, and which is also taken effort to program the needle movement to correctly match the simulator needle. So that's taken a lot of time doing the code for that, and then obviously the physical stuff. So if I take the covering off, you can see in here, those are all the real faceplates, and then underneath there's 3D printed pieces. And they were all printed on my 3D printer, which is the Ultimaker 2 Plus there, in its little housing. And when the needles move, they really look quite realistic because everything except the needle is real. So that's pretty cool. Again, looking forward to seeing that in the actual cockpit. So that's pretty much where the project is at right now. Like I said at the beginning of the video, I want to start doing this more often because it's starting to get interesting again. So if you want to catch the latest updates, be sure to like the Facebook page, Simulator Shane, and subscribe here on YouTube. Until next time, have a good one.